Welcome to this tutorial video about how to make sectional drawings and the assembly in MasterShip. So what we need to define the assembly and the sectional drawings is an imported hull model in MasterShip. We can easily recognize this because it's yellow, but we can also see here the surfaces that are used, indicating that it's imported into MasterShip. So what we actually want to achieve in this video is to make an assembly and sectional drawings, and that is looks like this. So this is in fact the yellow model that we've seen, but then divided into orthogonal slices, which are the frame drawings, also the longitudinal drawings, and the horizontal drawings, and then all combined into one assembly, as we call it. We can do also non-orthogonal drawings, for example, in the bow area, which is not explained in this video, but we do have content that does explain it. If we, for example, open one of these drawings, then here we can start defining the construction of the frame, etc., etc., and all that combined together will form the ship's construction. So, how to define this assembly? As said, we are starting with the imported shape model and defining the sectional drawings and the assembly. To do that, we start in the MasterShip organizer. The MasterShip organizer is found here in the MasterShip ribbon. It's a separate application. We can also search for it in Windows, and then it also opens. So this is the organizer. First, we need to open our project. I already defined this project as P123 concept design. If you don't have the project added yet, then you should do add and define a new project. So now the project is open. You can see that because we have plate reports. Here are some other things that we can do, but for now we are going to project and define the assembly. We are selecting the MSD that we have used, the MasterShip shape database, so the yellow thing in the background. And then it asks us to start defining the frame positions. What you want to do here is to define the frame positions in a logical way. So a logical place can be to start at the stern of the ship, or maybe at the rudder post. If I look at this ship, the origin seems to be about in the rudder post. This ship has a length of about 70 meters to the front and 5 meters to the aft. So what we could do, we could say, hey, we start defining from the rudder post, which is the origin. Therefore, we open a bracket, we say we start at 0, and we make frames until 70,000, which is the front of the ship. And we do that at an interval of 500 millimeters. So if we add this to the frame positions, then the software will generate intersections from 0 to 70,000 with an interval of 500 millimeters. So that will give us about 140 frames. For this tutorial, I'm going to make it a little bit shorter because of it will take some time to generate all these frames. So I only do it until 20,000. Um, so here it is. Then we can do also not frames by interval, but at a specific position. So we could also say we want a very specific one at 1400. And we can now also define the frames behind the rudder post. So we need to be quite exact here. Therefore, I'm going to take a measurement from the origin to the aft of the ship is 4,200. So the ship starts at minus 4,200. So this is the stern until I do minus 500. And I do that with an interval of, again, 500. And I add this. Now I see that we only defined intervals at the aft of the ship, and we defined also the direction of the frames aft. Usually what you want in the aft ship is to have the direction of the frame facing forward. So let us change that. And the reason for this is because the thickness of the plates can cause problems if you have it facing aft, because the shape of the ship usually converges at the back. Maybe just for the sake of clarification, we can also do some frames at 50,000, so a little bit more to the front of the ship, until 60,000. With an interval of, let's choose something different, 1200. Not very convenient, but just for illustration purposes. This is the front of the ship. It makes sense to do them aft. Here we can choose the starting number of the frame. So we have the rudder post as our reference. That should be 0. Then if we are going aft 4,200, so we should start at -9. And we cool minus, yeah. So, and our frame, but the prefix is frame. You could also say maybe frame or whatever you like. This is an important one. So the MSD contains both halves of the model. This is true in this fact. Our surface model indeed has a port side and a starboard. Sometimes you get models with only a starboard or only a port side model. In that case, our software automatically can mirror the model. That's not the case here, so we check that it does contain both halves. And we want to join intersection curves of the same surface. Now here we get an overview of all the frames that we just have defined. Looking at this, we made one mistake in the framing numbering, because frame -1 starts at 0, and that is not what I want, so I'm going to -8. And as you can see, the numbers just keep on counting. Same we can do for the longitudinal positions. This is in fact exactly the same process, so I'm going to skip over it a little bit quick. We do the center line at 0, and it starts at -8, so frame number -8, and it runs through the whole ship. I'm just going to pick a high number. And we make this centered because it's in the center. Apparently our highest frame number is 50, so and maybe we can do a second one. So we do center line plus or CL plus maybe 3000, and plus indicating to the starboard side. Also through the whole ship, but you could also modify it to whatever you like, and we are doing it towards the center line, etc., etc. Here the horizontal positions, I call this one tank top, at a position of 1000 millimeters, starting again all the way from the aft until the front direction is facing up. And I add it to the assembly. So now again, we get a full overview of all the drawings that sectional drawings that we're going to define. Here we can define some templates. You can make your own templates. I will show you later what those templates exactly mean. Here we get the option to define drawing units. Drawing units can be typically used for cooperation with your colleagues. So saying, hey, this person gets drawing unit 1, this person gets drawing unit 2. It's not the same as production units. It's completely separate. It's very much for the draftsman and is not related to any production process. So you could do that. What this function in fact does, it just separates your folder structure in here. So you will get a division over the drawing units. I'm going to skip this for now. I finished it, and now we will let the software just generate the assembly automatically. I'm going to close this one and also this one to start with a clean sheet. So here we have the shape. I go to the assembly manager for letting the sectional drawings being defined. When I click it, it will say the assembly will be created. I would say OK. All right, so the assembly is now generated. Let's take a look at our results. We have this new file assembly, and we also have a new folder, which is called assemblies, and there the assembly is found. Set the assembly contains all the intersectional drawings. We move this around a little bit, and then we see the structure. So here at the aft ship, we have defined all our frames at an interval of 500 millimeters. So this one is the stern, as we've seen. And here at the front of the ship, we define them at a bigger interval. This is the deck we have defined. Here's our center line. This is our center line plus 3000. In fact, I made a mistake by saying the port side was positive. The starboard side is positive, and the port side was the positive side. And yeah, so this is the assembly. And from here on, you can start defining your basic construction elements. Thank you for watching this video, and I hope to see you in the next one.